So we're going to look at the consequences of a type 1 and type 2 error. So for the first problem, it says that the mean tuition rate, so the mean is more than, so that's going to be greater than, the mean is going to be greater than, more than means greater than 20,000. That's going to be your alternative because it doesn't have an equal sign. Then your null is that the mean is less than or equal to 20,000. So a type 1 error is when you conclude HA when H naught is true. And what more correct language for concluding HA is actually rejecting H naught, or rejecting the null when the null is true. And if you reject the null, then there's sufficient evidence to conclude that HA is probably true. So you're concluding that the mean is greater than 20,000 when in fact, in reality, it's actually less than or equal to 20,000. Okay, so a consequence of this, so if you conclude that the mean is greater than 20,000 when in fact it's less than or equal to 20,000, then this, assuming the mean is more than, no, you're not assuming it's more than. You're actually assuming it is at most. At most, or no, sorry, you are assuming it's more than. That's what you're concluding. You're concluding that it is more than 20,000. So this is correct. You're assuming that the mean is more than 20,000. More students enroll in public universities and possibly miss out on the benefits of private education, because you're concluding, you're saying, hey, this tuition costs more than 20,000, when in reality, in fact, it's less than 20,000, less than or equal to 20,000. So if you're telling students that's actually greater than 20,000, then they might enroll somewhere else. So you're telling them that it's more than. A type 2 error would be to conclude H naught. So conclude H naught when HA is true. And more correct language would be to fail to reject the null when the null is false, right? If the null is false, that means HA is true, and you don't actually conclude H naught, you fail to reject H naught. But to make it easier to answer these questions, we're concluding the null, so we're concluding that the mean is less than or equal to 20,000 when in fact, in reality, it's actually greater than 20,000. So we're concluding that it's less than or equal to 20,000 when it's actually in reality more than 20,000. So less than or equal to is at most. So you're assuming, so it's this one. Or sorry, it's the one that says at most, it's this one. So this is your answer. You're assuming the mean is at most 20,000. More students enroll in private universities and graduate with more debt than expected. Because you're telling the students, no, the tuition is less than or equal to 20,000. But then when they actually go through the 4 years, they find out that it was actually more than 20,000. So you're kind of being deceitful to the students and not telling them the correct information based on making this type 2 error. Okay, so the chance of developing breast cancer is under 11,000. So P is less than 0.11. So that's your HA. So your null is actually going to be P is greater than or equal to 0.11. A type 1 error would be to conclude HA when H naught is true. And the more correct language, instead of concluding HA, it's actually rejecting the null when the null is true. If you reject the null, then there's sufficient evidence to support the alternative. So conclude HA, that means that P is less than 0.11, when in fact P is actually greater than or equal to 0.11. So you are concluding that the percentage of people of women that develop breast cancer is actually less than 11%, when in fact it's actually greater than or equal to 11%. So it's going to be this one. You're assuming it's less than. So this is the consequence. You're assuming it's less than 11%. Fewer resources are devoted towards research and development of new drugs than warranted. So you're saying it's a lot less than it actually is. So less resources are going to the research and development. A type 2 error would be to conclude H naught when HA is true. And the more correct language would be to fail to reject the null when the null is false. Because if the null is false, then there's evidence that the alternative is true, or you're favoring the alternative, and you don't actually conclude the null, you fail to reject the null. But to help us answer this question, you're concluding the null. So you're concluding that P is greater than or equal to 0.11, when in fact it is less than 0.11. So you're telling people the percentage of women that develop breast cancer is at least 11%, when in fact it's a lot lower than that. It's less than 11%. So it's this one, you're assuming at least 11%. Doctors prescribe preventive mammograms more often than may be necessary, because in reality it's less than 11%. So that would be a consequence of a type 2 error. All right, so for this one, Europeans have a mean paid vacation time. So the mean is 6. That's going to be your null. And your alternative is the mean is not equal to 6. So a type 1 error is when you conclude HA when H naught is true. And what the more correct language is, you're rejecting the null, and that's why you're favoring the alternative when the null is true. So concluding HA, you're concluding that the mean is not equal to 6, when in fact the mean is equal to 6. So it would be assuming that they have different from 6 weeks, not equal to 6. So assuming Europeans have a mean annual paid vacation different from 6 weeks, European travel destinations spend less on advertisements to entice tourists than they probably should. For a type 2, you're actually concluding the null when HA is true. And more correct language is fail to reject the null when the null is false. If the null is false, then evidence is favoring the alternative. So concluding the null, you're concluding that the mean is 6 when in fact the mean is not 6. So assuming, it would be this one, you're assuming that it is 6. Assuming Europeans have a mean annual paid vacation of 6, Americans start feeling resentful about not having as much paid vacation time as Europeans. Okay, so about half of Americans prefer to live away from cities given the choice. So P equals 0.50, that's half. That's your null, and then the alternative would be P is not equal to 0.50. So a type 1 error is to conclude HA when H naught is true. More correct language is to reject the null when the null is true. If you're rejecting the null, then you're favoring the alternative. So you're concluding HA, which is P is not equal to 0.50, when in fact P is equal to 0.50. So you're assuming that it's not half. You're concluding that it's not half. And that would be the consequence. Assuming the proportion of Americans who prefer to live away from cities is not half, more resources are devoted to urban development. As a result, housing supply falls short of demand in the suburbs beyond city limits and exceeds demand in the cities. A type 2 error would be to conclude H naught when HA is true. And more correct language is to fail to reject the null when the null is false. If the null is false, then there's evidence pointing that the alternative might be true. And you never conclude the null, you can fail to reject the null. But what does the null say? The null says that P equals 0.50. And what does the alternative say? It says that P is not equal to 0.50. So equals 0.50, assuming that would be this one. Assuming half of the Americans prefer to live away from cities, so assuming that it is 0.50 or 50%, more housing is built in the suburbs. As a result, too much housing is available beyond the city limits and not enough within the city limits. Because you're assuming that it is 50%, when in fact it's not 50%. The mean number of cars a student owns in the lifetime is not more than 10. So the mean is less than or equal to 10. Think about not more than. If you have not more than $10 in your wallet, you have 10 or less. So here's your null, and your alternative is the mean is greater than 10. So a type 1 error would be to conclude HA when H naught is true. And more correct language would be to fail to reject the null when the null is true. So concluding HA, you're concluding that the mean is greater than 10 when in fact the mean is less than or equal to 10. And you can see the language that they use here. Well, so this is a consequences of concluding that it's more than 10. So if you're concluding that it's more than 10, in reality it's less than or equal to 10, you're actually overestimating. You're overestimating the mean number of cars a person owns in his or her lifetime. Car dealerships end up spending more than they should to advertise new makes and models of the car because they think that people are going to own a lot of cars when in fact they actually own less than or equal to 10. A type 2 error would be to conclude H naught when HA is true. And the true definition is you're failing to reject the null when the null is false. So failing to reject because you can't actually conclude or prove the null. You're just failing to reject the null when the null is false. If the null is proved to be false, then there's evidence showing that the alternative might be true. So you're concluding that the mean is less than or equal to 10 when in fact the mean is greater than 10. So if you're concluding that it's less than or equal to 10 when in fact it's greater than, you're actually underestimating how many cars. You're underestimating the mean number of cars a person owns in his or her lifetime. Car dealerships choose not to advertise new makes and models as much as they probably should. Okay, so fewer than 5% of adults. So P is less than 0.05. That is your HA because it doesn't have an equal sign, and your null is going to be the opposing view, which is greater than or equal to 0.05. So if you make a type 1 error, you are concluding HA when H naught is true. So what's happening here when you conclude HA is you're rejecting the null, which is why you're favoring the alternative when the null is true. So you're concluding that P, what does the alternative say? The alternative says that P is less than 0.05 when in fact the null, which does the null say? The null says P is greater than or equal to 0.05. So you're saying the people that ride the bus to work, it's definitely less than 5%, when in reality it's actually at least 5%. So if you're concluding that it's less than 5%, you are saying no one's riding this bus, so funding is cut. You're saying, hey, the people riding the bus is less than 5%, so funding is cut to public transportation because people think no one's using it, and as a result, less public transportation is available than the demand necessitates, because the demand is actually saying that it's actually greater than or equal to 0.05. A type 2 error would be to conclude H naught when HA is true. And the more correct language is that you're failing to reject the null when the null is false. If the null is false, then you're favoring the alternative. The concluding the null, so what does the null say? The null says that P is greater than or equal to 0.05 when the alternative says that P is less than 0.05 is true. So if you're saying, you're concluding, people are definitely riding this bus, the people riding it is at least 5%, but in reality, it's a lot less than that. It's less than 5%. So a consequence is that resources that could have been spent on other things, for instance, get diverted towards public transportation because we're saying a lot of people are riding this bus when in reality, not many people are using it. Okay, so 29% of high school seniors get drunk each month. So P equals 0.29. So that is your null. It has the equal sign. The alternative is the opposing view, which it's not equal to 0.29. So a consequence of a type 1 error is to conclude HA when H naught is true. And what does HA say? HA says that P is not equal to 0.29. And what does the null say? The null says that P equals 0.29. So you're assuming that it is not, you're concluding that it is not 29%. As opposed to a type 2 error, you conclude H naught when HA is true. Concluding H naught, so you're concluding that it is 0.29, so you're concluding that it is 29%. when in fact